In this video, we are going to talk about upper and lower bound. If I round 6.7 to the nearest whole number, what I need to do is to cut it from here and check this one, right? So just because it is bigger than 5, I will be rounding 6.7 to 7 as the nearest whole number. What if I have 6.847 again to the nearest whole number? Well, I'm going to cut it from here and I'm going to check this number. Bigger than 5? Yes. So that's going to be 7. What if I have 7.314 to the nearest whole number? Well, okay, I'm going to cut it from here. I'll check this number. Less than 5? Well, it rounds down to 7. So there are numbers, actually infinitely many numbers, that will round up or down to 7. And this applies to any number. It's just an example. So the question is, what is the smallest number that rounds up to 7? Or what is the biggest number that rounds down to 7? Right. So let's mark 7 in the middle. So this is my number which I round up or down. I found 6.7, I found 7.1 something. So all these numbers rounded to 7. Now the question is, what is the smallest number and the biggest number that rounds up or down to 7? Now, if you go down to 6.5, you'll find out that according to the rule, 6.5 rounds up to 7, because the rule was you cut it from here and the number to the right must either be 5 or greater than 5. So 6.5 will round up to 7. So any number bigger than 6.5, all these numbers will round up to 7. So I can say that the lower bound, let's write here, lower bound for this 7 is 6.5. Whereas I know the same rule applies on this side. So if I go with 7.5, well, 7.5 rounds up to 8, because when you cut from here, this number is greater than or equal to 5, so I will get 8. But the numbers less than 7.5, because they will be something like 7.4 somethings, right? When I cut it from here, this number will be less than 5, so they will round down to 7. So any number less than 7.5 will lie in here and they will round down to 7. So if I want to write the upper bound, it will be 7.5. The best way to show upper and lower bounds is an inequality. Oops, let me clear this up. So this is 6.5, we said, that's the lower bound, and this is 7.5. So I'm going to say those numbers, which I don't know, so I call it as x, they will range between 6.5 inclusive, because I can round 6.5 to 7, and they will lie between 6.5 and 7.5. But of course 7.5 here will not be included. I can't include 7.5, because if I try to round 7.5 to the nearest number, I will end up with 8, right? So I can't include in this inequality 7.5, but I can still use it as an upper bound. And also in problems I can use it as an upper bound too. So I can I can make calculations with 7.5 as an upper bound. Let's see an example. In this one it says a rectangular sports field measures 21 meters wide and 83 meters long. Each dimension is measured correct to the nearest meter, so there is some rounding included. Now the question is, in part A, write down the smallest value that the width of the sports field could be. So we said it's 21 meters wide. Now, that's gonna be the number in the middle. So what are the lower and upper bounds? Actually, it's asking us the smallest value, so we can exclude upper bound for now. So the lower bound would be, and the number, the lower bound will be the number, the least number that will round up to 21. So I know the rule is that it should be 0.5, right? If the decimal part is 0.5 here, I can round it to 21. So I will end up with 20.5. Why? If I consider this number and cut it from here, here is 5. So it's greater than or equal to 5, so I can round it up to 21. So the answer for part A would be 20.5 meters. What I'm saying here is that the smallest length for the smallest value for width is 20.5. It could be 20.6, 20.7, 20.85, I don't know. But the smallest is 20.5. Work out the smallest possible perimeter for the field. Now, if the width is 20.5, how about the length? So if it is 83 to the nearest meter, then I should end up with, yes, 82.5. So it must be 82.5 meters the least. So for the perimeter of this sports field, which is rectangular, I should go like, well, 2 times 20.5, this is 41 meters, 2 times 82.5, this is gonna be 165 meters, and I will add them up because this is a rectangle. I have two 20.5s, I have two 82.5s, so it's gonna be 206 meters. So this bit is the answer for part B. Calculate the maximum possible value for the area of the field. So it says a maximum, so I should be using the upper bound. Now, if it is 21 meters, then the upper bound must be 21.5. Yes, I know, when I cut it from here, this rounds up to 22, but I'm not going to include 21.5 in my answer. So basically, the upper and lower bound in that inequality will be like this, right? I can't include it because it rounds up to 22. Still, I can use this number. So what's going to happen is, as these are the lower and upper bounds for the width, right? And these are the lower and upper bounds for length. Now, if it says the maximum possible value for the area, I should use the upper bound. So I will calculate the area to be 21.5 times 83.5, which would give me 1795.25 meters squared. Again, this is just the upper bound for the area, right? So it's gonna be the maximum possible value, yes, and we're just using the upper bounds to calculate that. If it was to ask us the minimum values, then I would use 20.5 and 82.5 to do calculation. Now try these exercises, solve them on your book, and submit your answers online.